Okay, from number 1C, we want to look at the distance matrix using the complete linkage. Using the complete linkage, so as you can see, we have the upper part of the matrix is the same so as the lower part. That is why this side was removed. So from the observation, we have 1 to 6 for this 1 to 6 and this 1 to 6. So using the complete linkage, the first thing we need to look at is the first stage to find the smallest distance in the matrix, which is 1.1. You can see, and this is in the cluster 6 and 3. 6 and 3. So from then we calculate the distance matrix for the cluster 6 to 3 by using this. So we have the maximum distance of 6 and 3. So we start from 1. So from there we have 3 and 1, 6 and 1. From there, so for the 6, 3 and 1, we have 3 and 1. 3 and 1, we have 3.5. For 6 and 1, 6 and 1, 1 and 6, we have 8.6. From there, we pick the highest number here, which is 8.6. So that's what we are going to do for 2 also, for 4, and down to 5. So from there, the highest numbers is going to be the one that we'll pick. From here, we're having 4.8. For this, we have 8.3. Then for this, we have 10.1. So that is the new value for the clusters. So we are going to move and calculate the new distance for cluster 6 and 3 or 3 and 6. So this is our new table. You see that 6 and 3 is now matched together to one cluster. So from there, we are going to remove the values we have and replace it with the new numbers, which was picked from the first stage. So from there, the table will become this: 0, 4.1, 4.3, sorry, then this 8.6. So the values we're going to input. So we are going to be having a reduction in the cluster. So from before it was 1 to 6. Now you see what it has become: 1, 2, 3 and 6, 4 and 5. So looking at this, you are going to move to the second stage. At the second stage, you are going to find also the lowest distance in the matrix, and that is 4.3. You can see it here. And this is at the cluster 1 and 2. So from there, we are going to also calculate that respectively. So we are going to pick it. If you pick 1, you can't pick 1 because 1 is already in the cluster, which was picked from the table and from the matrix. So we are going to start from cluster 6 and 3. So for cluster 6 and 3, this is this. So the maximum distance of 1, 2, and 6 and 3. So from there, you take this 6 and 3 to this 1, then 6 and 3 to this 2. So from there, you have 1, 6 and 3. This is 1, 6 and 3, this value, this here, and that is 8.6. For cluster 2, 6.3, where is that? We have 6, that is 6 and 3, then 2. That is this value, which is 4.8. So from 8.6 and 4.8, we are going to pick 8.6. The same thing we are going to do for 4, and we're going to do for 5. So we pick the respective highest numbers. From there, we are going to move to the next one. So a new table for cluster 1 and 2 will give us this. So cluster 1 and cluster 2 is now matched together, which has done, that is a linkage between that. So we are going to see it at the end of the day, denograms of that. So that means that 1 and 2 is linked together, 3 and 6 is linked together. So let's continue. You will see the table at the end of the day. So the third stage is to find the smallest distance in the matrix. Here you can as well see that the smallest distance is 8.3 and the highest is 18.3. So you can see here that this is the cluster of 4 and 3 and 6. So therefore, 4 is linked to 3 and 6. So with that, we can also calculate the respective clusters to match up with what we're going to have. So from there, you are not going to deal with 3 and 6 and 4 anymore. You are going to deal with 1 and 4, 1 and 2, sorry, and 5. So margin shall checking the distance, the maximum distance between 4, 3 and 6 and cluster 1 and 2 will give us this. So taking 1 and 2 to 4 and taking 1 and 2 to 3 and 6, which is now one entity. So you are going to have 4, 1 and 2, then 3 and 6, cluster 1 and 2. So with that, you have 10.2 and 8.4, 6. So what can be the highest number here? You can see it's 10.2. The same thing we do for 5. So which will lead us to the table, the new table we have here. This is the new table distance for matrix cluster 4, 6 and 3, or 3 and 6. So from this table, you will see that the lowest number here is 10.2. So what we can calculate here, that means that cluster 1 and 2 is now linked with cluster 6, 3 and 6 and 4. So that means there's a link there. The relationship is between them. So we are going to also check. So now, if this is linked to this, the only value we have remaining is 5. The only value we have remaining is 5. So from there, we can only calculate using the cluster 1 and 2, 4, 3 and 6 to calculate for 5. So using that, this 5 will go to 4, 3 and 6. 5 will go to 1 and 2. So from there, we have the highest number to be 18.3. That will take us to the last matrix table, cluster table, in which you can see that the highest number here is 18.3, which is the last number. So that will take us to the dendrogram. So from the dendrogram, you can see the linkage. The linkage is that the first number, observation 3 and 6, observation 3 and 6, observation 3 and 6 was linked up. Observation 3 and 6 was linked up, and observation 1 and 2 was linked up. From there, 4 was linked up to this, and the observation 5 was linked up to every part of the other observation. That has explained all the questions we have for question 1A, 1C, A1, C1 and C2. So all the questions have been mapped up in this, and that is it also. So all the dendrogram was mapped up, which shows how the linkage was done.